Okay, guys. You need to have the shapes written in there. There was a couple of you did. There's a couple of you didn't have it done. You might be able to finish it today with the information I'm going to give you on the board here. Okay. So, first thing I'm going to ask you is let's identify all the different shapes that you guys have written down, and I'm going to write them up here. You don't have to write this down right away. Okay. I'll post this on Google Classroom. If it's something that you want to go to later and write down in your notes later, you can do that. So, we want to write down all the shapes that we know. So go ahead and give me some names of different shapes that we identified.
Tetrahedral.
Okay?
Bent.
So we have tetrahedral.
Linear.
Yeah. And I'm putting it in a certain order, so
Trigonal Pyramidal.
yeah, bent and linear.
Trigonal Pyramidal.
Seesaw. Yep, Trigonal Pyramidal.
Octagonal. Tetrahedral.
Tetrahedral. Pyramidal. Trigonal planar.
Trigonal Pyramidal.
You don't have it here.
I just want to suffer.
Yeah.
Okay, so we have these 5 shapes, all right? And so we have branched atoms we talked about, and that's kind of how you used it to figure out the shape. And then we have lone pairs. Lone pair, unshared pair, they're synonymous, they mean the same thing. So let's just take a look at tetrahedral. Okay? So tetrahedral, how many branched atoms?
4.
Okay?
Whoa.
How many lone pairs?
0.
0. Okay, so every time you get 4 branched atoms, and you're pretty much going to have 0 lone pairs, and that's always going to be tetrahedral. All right? So this structure's tetrahedral, and I'm going to go ahead and draw this out. It might not be an example that you guys did. So those are just pairs in between there. So tetrahedral kind of looks like a pyramid, but it's a tetrahedral shape. You have the triangle on the bottom base, tripod base, and then kind of like an antenna sticking up. That would be what you'd have in that scenario. Okay? Trigonal pyramidal. Branched atoms, how many? How many lone pairs?
0.
Okay, 1. And so that would be like this one here. Now, when I draw these shapes, I'm trying to draw them with the shared pairs, kind of like it would look if it was kind of looking from the side. So that would be a trigonal pyramidal there. Okay, trigonal planar. Three, 0. Okay, and then so that would have been like this one. So some of you that did not have all the shapes done, you probably can look up here and you could probably start writing some shapes down of some that you haven't done yet. Okay? So, this is kind of, these are all on one plane. So if we would set it down, it would look like a propeller with 3 props. Okay? And they're equal distance away from one another. So that's a trigonal planar. So, we only got 2 more shapes. This last one, bent, is going to be how many? 2 and... Is there another type of bent?
Probably.
Well, why don't you look? Because it should be on there.
Yeah.
2, 2. Okay? So 2, 2 would be
Oh, yeah.
another one.
Why do we have because you put unshaped hair on it?
Okay? So, this would be, water is one that's bent. Okay, so that's one. And then I'm not going to show you the other one. I'm kind of running out of room. But if you have 2 bonded atoms and then you got one that's unshared pair, that's going to be a bent. And then linear. What do you have? 2, 0, or 1, 0. Well, we really don't have a central atom when we got 1, and then I'm just going to put a dash here because it really doesn't matter what's off that other one because it's kind of like connecting dots. When you connect them, it's always linear when you got 2. So the one that's 2, 0, that's linear would be like CO2, where it has 2 double bonds. That would be an example of linear. Now, you guys didn't have to do these. If you want to do them, you can, because you've got examples. That's your notes, guys. What's in front of you, all those different drawings and that's kind of your notes that you can look at if you need to study and look at shapes and how they're done. Okay? Now, eventually, and it's not that difficult, eventually you'll have to draw the structure and then you'll have to tell me the shape of it. Okay? Now, we're gonna take it one step further. I'm not going to be able to go through much of this today because I'm running out of time. 3rd period. But what I want to do is I want to take a look at this one structure and then I want to talk a little bit, instead of showing the dots, I'll show the line, and that each line represents a shared pair. So, I'm not going to have you do it, but there's this thing called electronegativity, and you can look it up. I'm not going to have you do it. And it's on the periodic table. And it describes a sharing that will take place between 2 bonded elements. Okay, the higher the number, the more of a share that it's going to have. So, hydrogen's 2.2, its electronegativity. And nitrogen is 3. Okay? So, let's just look at this bond right there. Which element has the electrons closer to its symbol? Hydrogen? Does hydrogen have those electrons that are shared closer to its atom? Or does nitrogen have it closer to its atom? And you can look at the numbers, and they tell you. So 3 versus 2.2. So which one do you think would have more of a share? Nitrogen. In all 3 cases, right? Because they're identical. So if you guys remember, to kind of show that there's a difference in polarity, we did this line with an arrow. Remember that? Remember that?
Yeah.
About 2 weeks ago. where we said if it's non-polar, polar, or ionic. You remember? We kind of did an assignment on that. In fact, you probably have it back. And we do 3 arrows pointing toward nitrogen. So if they're all pointing toward nitrogen, okay, this upper section here of that tripod, that top section, is negative. Okay? And this bottom section here, I know there's a lot going on here. Okay, so I'll write it over here again without all the numbers in that. But this bottom section here is positive. This top section's negative. So if I had another one of these molecules floating around, which if I have one, I've got trillions and trillions of them floating around. Will these two here attract one another based upon what I just gave you? When they move past each other, do you think there'll be an attraction between the two?
Yes.
Right, because they're polar. Because it's like magnets, north-south side of the magnet, they pull together. So, and it also depends upon how strong that's going to be. If there's a big difference in electronegativity, which is, here it's 0.8. If it's higher than that, like 1.5, 1.6, 1.7 difference, that's a stronger polarity, and so you have an attraction that'll take place between these two. And then that's called we'll talk about tomorrow, an intermolecular force. So molecules actually attract one another, sometimes more than others. And we'll talk about that over the next few days, about polarity and how it affects the attraction between molecules. Okay? All right, at this time, what I need you to do, I need you to get out a piece of paper. I need you to number 1 through 4. Space them evenly. Okay? If you would do that.